Do you ever look up at the night sky and feel it? That strange pull, that quiet voice asking, "Is anyone else out there?" If you've ever felt that, this series was made for you. And I promise you, by the time we're done, the universe will never look the same again. Two possibilities exist. Either we are alone in this universe, the only spark of consciousness in an ocean of darkness stretching 93 billion light-years in every direction, or we are not alone. And here's the thing that stops people cold when they really sit with it. Both of those possibilities are terrifying. Arthur C. Clarke said it best, and he was right. Because if we're alone, the silence is deafening. And if we're not, well, then something is out there, and we haven't met it yet. This is life beyond, a journey through the most profound question humanity has ever asked. Not a question of politics or economics or even survival, a question of identity, of meaning, of our place in the cosmos. And for the first time in human history, we are not just asking the question philosophically. We are building the tools, launching the probes, and pointing the telescopes that may finally give us an answer. Think about what that means. Every civilization that has ever existed on this planet, every empire, every philosopher, every child who ever stared up at the stars, they all wondered, and none of them knew. But we might, in our lifetime. That is not a small thing. That is one of the most extraordinary moments in the entire history of our species. We are the first generation with a realistic chance of answering the oldest question ever asked. In this series, we're going to travel through time and space to explore what life really is, where it might exist, what it might look like, and what finding it would mean for us. We're going to visit the frozen moons of our own solar system, peer into the atmospheres of distant worlds, and ask questions that science is only now beginning to answer. We're going to look at the raw numbers, and those numbers are staggering. We're going to look at the chemistry, the physics, the biology, and the philosophy, because this question touches all of it. But before we can search for life out there, we have to understand life right here. And that turns out to be a much harder question than most people expect. What is life exactly? We all think we know. We can point to a tree, a dog, a bacterium under a microscope and say, yes, that's alive. But when you try to define it, when you try to write down the rules that separate the living from the non-living, things get complicated fast. Scientists have proposed dozens of definitions over the years, and none of them are perfect. Every definition either includes things we don't consider alive, like fire, which consumes fuel, grows and reproduces in a sense, or excludes things we do consider alive, like viruses, which can only replicate inside a host cell. The boundary between life and non-life is blurrier than we like to admit. And that complexity is actually the key to everything that follows in this series. Because if we can't perfectly define life even here on Earth, how do we know what to look for elsewhere? How do we design a test for life on Mars, or in the clouds of Venus, or in the oceans of Europa, if we can't agree on what life fundamentally is? These are not just philosophical puzzles. They are practical scientific challenges that researchers are actively working on right now. Here's what we do know. Life, as we understand it, is chemistry, not magic. Not some mysterious force that descends from the heavens. Chemistry. The same atoms that make up rocks and stars and the air you're breathing right now. Those same atoms, arranged in just the right way, under just the right conditions, can organize themselves into something that moves, grows, reproduces, and eventually looks up at the sky and wonders where it came from. That is the miracle. Not that life is supernatural, but that it is natural, and yet still so astonishing. And if life is chemistry, then the question becomes, where else in the universe do those chemical conditions exist? Where else is the recipe being followed? Because here's what the last few decades of astronomy have taught us. The ingredients are everywhere. The raw materials for life are not rare. They are not confined to Earth. They are scattered across the galaxy in quantities that are almost impossible to comprehend. Water, the molecule that makes life on Earth possible, has been detected in interstellar clouds, in the atmospheres of distant planets, locked in the ice of comets that travel between the stars. Organic molecules, the carbon-based building blocks of biology, have been found in meteorites that fell to Earth from space, in the dust clouds between stars, even on the surface of a comet visited by a spacecraft. The universe is not a sterile, empty place. It is a vast chemical laboratory, and it has been running experiments for nearly 14 billion years. The raw materials are there. The question is whether the assembly has happened. So why haven't we found anyone yet? That question, known as the Fermi paradox, is one we'll return to again and again throughout this series. Because it haunts every scientist who works in this field. The numbers say life should be common. The silence says otherwise. And the tension between those two facts is where the most interesting science lives. It is a tension that has generated some of the most creative and unsettling ideas in modern science, and we are going to explore all of them. Over the next 13 episodes, we're going to dig into every corner of that tension. We'll explore the origin of life on Earth and what it tells us about life elsewhere. We'll visit the most extreme environments on our own planet, places where life thrives in conditions that would kill you instantly, and ask what those extremophiles tell us about the possibilities on other worlds. We'll look at the planets and moons in our own solar system that scientists consider the most promising candidates for life right now. We'll examine the thousands of exoplanets discovered in recent years and ask which ones might be home to something living. We'll think about what intelligent life might look like, how we might communicate with it, and what the consequences of contact might be. We'll also spend time on the human side of this story, the scientists who have dedicated their lives to this search, the instruments they've built, the setbacks they've endured, and the moments of genuine excitement that have kept them going. Because the search for life beyond Earth is not just a scientific endeavor, it is a deeply human one. It reflects our need to understand, our refusal to accept that we might be alone, and our courage to ask questions whose answers might change everything. And we'll ask the deepest question of all. If life is out there, and if some of it is older and more advanced than us, what does that mean for who we are? What does it mean for our religions, our philosophies, our sense of purpose? These are not questions with easy answers, but they are questions worth asking. And this series is going to ask them honestly, without flinching. If you're new here and this is the kind of content that makes your brain light up, hit that subscribe button and turn on notifications, because this series is just getting started and you won't want to miss a single episode. Every episode builds on the last, and the journey gets more extraordinary as we go. We are standing at the edge of one of the greatest discoveries in human history. The search has begun, and in the next episode, we're going to go back, all the way back, to the very beginning of life on Earth, to understand the recipe that started it all. Stay with me, because what comes next changes everything. If this got you thinking, you're going to love the next episode. It's already queued up for you right there. Hit subscribe if you haven't yet, and let's keep exploring together. The universe is waiting.